Welcome to TEC Tube. I'm Dave Herman. Today we're going to be installing a GREE FLEXX unit. GREE FLEXX unit comes in two sizes, a 2 3-ton and a 4 5-ton. This is going to be installed with an A coil. With the application, we'll be able to run this as a 2-ton along with that 2-ton coil with that existing furnace I mentioned. With me on this installation today, I'm going to have Ryan assisting me and Neil. We're going to get this installed from the very beginning to the end. We've already gotten the unit pulled out that was existing, and we have the A coil set, and from here on out we'll be running the lines, the electric, tying everything in, pumping the unit down to the 500 micron point, and then we'll be starting it up and operating it. Along with that, we'll be setting up the thermostat, so it will be set up for heat pump operation and AC operation. So this unit is a heat pump itself and can be used just as an AC or in heat pump application. You do have that option. So we'll be going through that along with all the other basic installation practices. Okay, we're at a point now where we have the unit roughed in. We have our lines out. We have our whip ready to go. We have our thermostat wire out. We have our unit set on the stand. We have it off the ground for the defrost mode. And then also the concern that we have if we have some snow building up, but the main thing is for the defrost. On the bottom of the unit, there's openings. There's 4 openings. There are 3 plugs that are provided and then an actual drain. For any drain openings that you may not need or may not be using, you could plug those up. It also gives you a fitting that you could hook up a hose to, a 1/2-inch hose, in case you have this installed somewhere inside or where you need to run the water off somewhere else. Aside from the drains, we have the lines. We have these FLEXX connectors that we got purchased via GREE. GREE provides these separately from the unit. These make it easier to make these connections and get out of the unit. They're the flare connections, pre-flared, and then the back end of them, we're just gonna braze and attach to them. So we have our lines run, we'll hook these up. We have our valves, which are just like our standard valves we have on any residential condenser. So we're gonna get going with this. We're gonna get everything tied in and we'll get it running eventually. We have our refrigerant lines tied in and fitted. So we're ready to go. We've got our flares connected. We just have to tighten those down. On our suction side, we're gonna tighten down that flare fitting to 51 to 55 foot-pounds. And then our liquid side, the 3/8 side, we're gonna tighten it to 26, 29 foot-pounds. Also, we have our gauges hooked up, ready to go. We're attached to our nitrogen tank. We will be doing a nitrogen purge as we braze at our braze points. With the hoses on the gauges, we will need an adapter on these. We're gonna have to go from 1/4 inch to 5/16. So we have our adapters on, and then we have our hoses for our gauges ready to go.
We got our thermostat wire connected up on here. It's a 5-wire application, right? So we have our normal Y and C, just like we always have to turn the compressor on. That's what we have on a standard AC unit. Then additionally, we have a few more things on here. We have a reversing valve. This is a B-style reversing valve. This unit defaults to cooling, and we will have to flip it over to heating by energizing the reversing valve from the thermostat. So that's the B wire in blue. Then we have 2 other wires here. In this case, we have white and red. Red is hot, and then white is gonna wire back to the W on the furnace. On this unit, it's labeled with a D for defrost. So what's gonna happen is the thermostat can turn the furnace on for gas heat, or when this unit goes into defrost mode, it can turn the furnace on for gas heat. So we go into defrost mode, we operate like a regular air conditioner, which means there could be cold air blowing on people, so we turn on the gas heat to temper that back up. So that's our 5 wires that we have set up on here. There's also 4 dip switches on this guy. So the first dip switch over here, and as you'll notice, these are upside down. That's unfortunate. I can't explain why they did it that way, but they are upside down. So the number 1 is on the right side. The default position is making this a 3-ton unit. We only need 2 tons in this application, as you can see by our load calc. So we're gonna set this up for 2 tons. So I'm going to flip this dip switch number 1 to the off position, which is up in this case. Dip switch number 2 is for defrost. The default mode is standard defrost. You can flip it to strong defrost if you want. What strong defrost would do is it would run a longer defrost cycle. That's less efficient, and it does have cold air blowing a little bit longer, which are neither one of those are ideal, but if you're going to run it in very, very cold applications, you need to do that. In this case, we're in a cold climate application, but we have a dual fuel system with a gas furnace, so we'll just switch over to gas heat at that time. So we're going to stick on standard defrost. The next two dip switches work together. You have 3 choices there. You can have standard operating mode, which is what we're going to pick today. You could have the aggressive operating mode, right, where we can run this thing and ramp it up even faster than normal, kind of like mini splits do. Or you can have the eco mode, which dampers it down, right? So if you ever had a car, you might have a button on your car that switches between standard mode, sport mode, and eco mode. So eco mode is your more efficient mode, but less responsive. Sport mode is your aggressive, fast, give it to me now. In this case, give me cooling right now mode. And then we have standard. So we're gonna leave it on standard. So our dip switches in this case are gonna be up for 2 tons, down for standard defrost, and up for standard operating mode.
All right, so this question here specifically is asking us if we want to energize the reversing valve on cooling or energize the reversing valve on heating. For the GREE FLEXX unit, it's going to default to the cooling mode, and then we have to tell it we want to reverse for heating. So we're going to switch that. How is your OB reversing valve energized? Energized on heating. Allow the heat pump and aux heat to run simultaneously. So if we had an electric heat as our other source of heat, we would say yes, run electric heat and heat pump together, but we don't, we have a gas furnace. So at a certain outdoor air temperature, which we'll talk about in a minute, we're gonna shut off the heat pump and then we'll turn on the gas furnace instead. So we'll say disable for this question. Configure the compressor minimum outdoor temperature. The compressor will not run below the outdoor temperature. We recommend disabling this option unless your heat pump manual notes say otherwise. Right? So we can lock it out at a certain temperature if we want. We did the economic balance point on this guy. So you can see that up here. For this particular unit, we have a pretty good stability of the BTUs. So whether we're at 47, 17, 5 degrees, we're pretty close to 2 tons of heating either way. That's why it's a fairly straight line compared to the traditional heat pump. So in this example, for the load of this specific house, which was about 29,000 BTUs, we are going to be not able to heat the house with the heat pump solely at 12 degrees and below. So in this case, disable the heat pump, I'll say at 15 degrees. Oops, 15 degrees. What kind of heating do you have in your home? We have a furnace in this case. This setting here in the installation settings, aux heat outdoor temperature, you want to go to that one specifically. And in this case, do not run the auxiliary heat, which in our case is a gas furnace, above a certain temperature. So we know the heat pump could do it down to 12 degrees based on our balance point. However, based on the cost of electric and the cost of gas at this customer's home, the economic balance point was around 40 to 45, somewhere in that low 40 range. So I'm gonna go ahead and change this to 45 degrees. So when it's above 45, we'll use the heat pump. When it's below 45, we will use the gas furnace.
We've got everything brazed in, got the vacuum pump hooked up, we've got our micron gauge on. We're looking to get down to 500 microns per the manufacturer requirement. So as far as that goes, we're making good progress. As far as the charging goes on this unit, we're under 25 foot of line set on this, so there's no need for added charge. You could reference the charging chart for any changes beyond that 25 feet. The unit's up and running, everything looks good. We confirmed our temperature drop inside in the AC mode at 19 degrees. So it looks like it has been a success.